Since 0 cannot be taken in the first place, we are left with 6 numbers. 10,000 place can have only the number 2. So therefore I have only one choice for the first place. I have to split the question into two cases, that is first digit starting with 5 and first digit starting with 0. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am, lecturing in Vidhyaashram, Department of Mathematics, the Temple of Excellence, Mysore. So, welcome to the third session of Permutations and Combinations. Okay, so let us recall what we have learned in the session 2. So, permutations and combination is based on arrangements, as I said. So in our previous session, we have learned how to arrange different people's number of books in different orders, how when we change the order, when all the same books occur together, or for example, when men and women are sitting together, when they sit alternatively, how we will arrange them. When all the men sits together and all the women sits together, how we will arrange them. So these kind of problems we have learnt, that is from type 1 to type 4. Okay, so based on repetitions and non-repetitions. So that is what we have done in our previous sessions, that is arrangement of people and books. So in today's session, we will be learning about the formation of digits, how the numbers can be arranged. For example, let me take an example like 1, 2, 3, 4, 5. So you are asked to find a 3-digit number. So you know the place values of 3-digit number. What are the place values of 3-digit number? We have 3 digits number. So this is your units place, tens place, and 100 place. Okay, so go back to your primary school and remember the place values. Come back now for the second PUC concepts. Now you're asked to find out a 3-digit number from these 5 digits. So how many digits we have here? We have 5 digits. So we are to choose any 3 digits number to form a 3-digit number. Suppose I take 2, 3, 4. So what does it mean? 234. Okay. Suppose I change the order. I'll take the same 3-digit number. I'll just change them, rearrange them. So 3, 2, 4. We can clearly say that this is not one and the same. So even though I repeat the digits, when the order is changed, the meaning also changes. Okay. So that is 234 is different from 324. So this is what happens in the formation of digits. Also, we should be very careful that if one digit can be repeated, other digits can have the same place value, that is 1, 1, 1. For example, we can have 323, we can have 554. So we come across these type of numbers where digits are repeated. Also, we come across these types of numbers where digits are not repeated. But you must be very sure that when the order of the number changes, the digits also changes. So here also, in the formation of numbers also, we come across permutations with repetition of numbers, permutation without repetition of numbers. Okay, so first case we will choose when that is without repetition and when there is no restriction. What do you mean by restriction then? Let me take an example now. So the same example I'll take. I'll take 1, 2, 3, 4, 5. Now you are supposed to do 3-digit numbers. So let me take 3-digit number. As I said, the digits can be repeated and the digits may not be repeated. Okay. So let us assume we are supposed to form a number where digits are not repeated. Okay. So these two things you must be very careful. That is digits repeated and second one, digits not repeated. So in solving the statement problems also, you must be very careful that is this statement is given. If they have given digits not repeated, then you are not supposed to take the chances of choosing the same digits in the same place. Okay, when nothing is given, it is understood that digits are repeated. Okay, so in this syllabus, in your second PUC, most of the problems we are doing where digits are not repeated, but make sure when nothing is given, you should consider it as digits are repeated. Okay, you can choose all the numbers for each place values. Now, let me tell you about digits not repeated. So, I'll take 1, 2, 3, 4, 5. So, you are supposed to form 3-digit number. So, we have units place, tens place and 100 place. So, I can fill all the numbers. I can fill all the numbers in any of the places. So, my condition is to choose 3-digit number among 5-digit number. Okay. So, this can be taken in the formula of permutation as 5p3 also. So, this is one type of logic we use the formula method. Okay, but this is not useful for all the calculation when there is restriction. So, we will tell about the restriction later. First, let us consider. So, I can choose any type of number here. So, I am talking where digits are not repeated. So, let us consider the first place where the 100 place. So, I can put 1, 2, 3, 4, 5. So, I have 5 choices for this place. I have 5 choices for this place. So, what you can do here, let me consider 1 is gone now. So, because let us take, I have filled 1 in 100 place. How many numbers are left? So, we are left with 4 numbers. So, therefore, in the tens place, I have only 4 choices. Okay, now let us take 1, 2 is gone. How many numbers are left? Only 3 numbers are left. So, I have only 3 choices in the units place. So, therefore, my answer or my total number of permutation for these numbers where digits are not repeated is 5 into 4 into 3. So, how much? 60. So, this is one more logic which is equal to 5p3. Okay, so remember when digits are not repeated, you cannot have the same choices on each place. Okay, so therefore, this is an example where digits are not repeated. Let me take what happens when digits are repeated. The same thing. So, I will take hundreds place, tens place, units place. I can fill all the numbers from 1 to 5 in hundreds place. So, I have 5 choices. I can fill all the numbers again in the tens place also. Again, I'll have 5 choices. The same thing will happen for the units place also. Why? Because we have learned digits like this repeat. We can have choices. The same choices we can choose in each place. So, here what happens? 5 into 5 into 5. So, that is 125 of ways of permutation or total number of digits with repetition is 125. From the same numbers without repetition is 60. So, this 5p3 is a formula method and this is one more logical method we use, but this is not possible to calculate the number of permutation where numbers repeated or where numbers do not repeated when restriction is there. Okay, so this is not possible. Okay, so let me tell you about now what do you mean by restriction. So, before going to the restriction for the digits, let me take case 1 when there is no restriction. So, when there is no restriction, how many different 4-digit numbers can be formed using the digits 1, 2, 4, 5, 7, 8, 9. So, how many digits we have here? Just look at it. We have 1, 2, 3, 4, 5, 6, 7. 7 different digits. That is 1, 2, 4, 5, 7, 8, 9. What we are supposed to do? We all have to form a 4-digit number. So, 4-digit numbers. Okay. So, let me take 4-digit numbers. So, this is your units place, tens place, hundreds place, and this is thousands place. Okay, so we are very clear that, so out of 7 numbers, we are going to form 4-digit number where no digit being repeated. So without repetition, okay, we are not repeating the digits. So this, by using formula method, we can clearly write, so how many numbers we have? 7 numbers, out of which we have to form 4 numbers. Okay, so this can be formulated using permutation formula 7p4. So let us use this logic also. This is one other type to find the number of permutation. I can fill all the numbers from, what are the numbers I have given? 1, 2, 4, 5, 7, 8, 9. Let me take 1 is filled in the 1000 places. So if I fill 1 in the 1000s place, so then the series starts from 1000, some like 100, tens like that. Okay, all the series starts from 1. If I take 2, all the series starts from 2000, some 100 and some 10 like that. Okay, so like that, if I fill any one number in the thousands place, I cannot repeat the number. So for the first place, I can have all the choices. That is 1, 2, 3, 4, 5, 6, 7 choices. So the first place has 7 choices. Okay, so let me take 1 is gone now because I have filled in the first place. So how many numbers are left now? So 1, 2, 3, 4, 5, 6. So 6 numbers are left. So therefore you have 6 chances to fill in the 100 place. Next place. So after you have filled 1, I'll take 2 is filled in 100 place. So 1 is gone, 2 is gone. How many numbers are left? We are left with 1, 2, 3, 4, 5 numbers. So we have 5 choices in the tens place. Similarly, take 1, 2, 4 is gone. How many choices we have? So that is 4. What do you mean by 7p4? Choose 4 factors of 7 factorial. That is 7 into 6 into 5 into 4. So is it one and the same? So these are 2 methods to find. Okay, one is formula method. This is one more logical method we can use. Okay, so therefore here, so total number of 4 digits. Total number of 4 digits is 7 into 6 into 5 into 4. Okay, that is 7 into 6 into 5 into 4. So that is 840. So 840. So here also this is 840. So this is what my first case, that is when there is no restriction in the place values. Okay, how can I form digits, certain type of digits using the given digits? So my first question is, here they have given 7 numbers. We are supposed to form 4-digit numbers without repetition. So once again I'm telling, without repetition means if one value is fixed for the particular place, you cannot repeat the digit in other places. So therefore, if 7 places you have choices for 1000 place, then you have 6, 5, 4 in the hundreds, tens and units places. So therefore, the answer for this question is 7 into 6 into 5 into 4, that is 840 ways or 840 digits, number of digits you can form using 1, 2, 4, 5, 7, 8, 9. Okay, so let me take the next question. So case 2. So here we come across restrictions. So here we come across restrictions. So what do you mean by restrictions? So let me take an example in case 2 now. So numbers divisible by a particular number or even number or odd number. Okay, so we have divided into case 1, case 2, case 3 so that you can easily understand it. Now we are coming across the restrictions. Okay, what do you mean by restrictions? So let me take an example again now. How many 4-digit even numbers can be formed from the digits 1, 2, 3, 4, 5, 6, no digit being repeated? Remember, digits are not repeated, so this is without repetition. Okay, what are the numbers they have given? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. What am I supposed to do? I have to form 4-digit even numbers. Even numbers, not any other number. Only even numbers you have to form. So we have 4-digit even numbers now. This is your units place, tens place, hundreds place, and this is your thousands place. So what do you mean even number? Even number always ends with even numbers. Okay, any even number, any 4-digit number or 3-digit number or 5-digit or 6-digit number, even numbers means the number should always end with even numbers. So I cannot fill 1, 3, 5. So this is not possible. This is not possible. If I put 1, 3, 5 on the units place, this will become odd number. So therefore, where is my restriction? My restriction is in the units place. So whenever the restriction is in the particular place, fill the particular place first. Since I have the restriction on the units place, first let me fill the choices of the units place. So what are the choices I have for unit place? That is only 2, 4, 6. So I can fill 2, 4, 6 in the units place. So how many choices we have for the units place? That is only 3 choices. So we have only 3 choices. Okay, I cannot put 1, 3, 5 here because it becomes an odd number. Since I am supposed to form an even number, I have only 3 choices, that is 2, 4, 6. Okay, now consider the same repetition. So here digits are not repeating. Let me take 2 is filled now. 2 is filled in unit places. Come across the remaining places. Let me take 2 is gone now. Okay, so 2 is gone. How many digits are remaining? 1, 3, 4, 5, 6. That is 1, 2, 3, 4, 5. So I have 5 chances or 5 choices to fill for the thousands places. Okay, if 4 is also filled, we have 5 choices. If 6 is also there, we have 5 choices. Okay, take any number in the units place, you are left with 5 numbers. So therefore, we have 5 chances or 5 choices to fill in the thousand place. Now, since digits are not repeated, units place has taken one number, thousand place has taken another number. How many numbers are left? So we are left with 4 numbers. So that is 4 choices for the 100 place, and similarly 3 choices for the tens place. So therefore, what is my total number of permutations or total number of 4 digits here? So therefore, my total number of 4-digit numbers, 4-digit, not only numbers, 4-digit even numbers. So what is that? 5 into 4 into 3 into 3. Okay, 5 into 4 into 3 into 3. So remember, because why 3 in here? Because since we are supposed to form even numbers, units place have only 3 choices. So 5 4s are 20, 23 is a 60, 63 is a 180. So 180 4-digit numbers can be formed. Next question. Again, here we come across restrictions. Here also we have restrictions. But the thing is, you have to find where is the restriction. So whenever you have a restriction, you have to find the place where is the restriction, and you should fill the choices of the restriction place first. Okay. So let me take numbers greater than or lesser than a certain number. Okay. Numbers greater than or lesser than a certain number. How many 5-digit numbers can be formed with the digits 2, 3, 5, 7, 9, which are less than 30,000, greater than 70,000, between 50,000 and 90,000, greater than 75,000. Let me take them one by one. Okay. So 5-digit numbers we are supposed to form. We have 2, 3, 5, 7, 9. Okay. Now, let me take the first question. This less than 30,000. Less than 30,000. I am taking 5-digit numbers. So, less than 30,000 means the restriction is in the first place. Okay. Suppose if you write 5 here, all the series starts from like 50,000, some hundred and like that. If I write 7, all the series starts from 7. If I write 3 also, it starts from 3. But my question is less than 30,000. So the only choice I have here, that is 2. Okay. So we have, so 5 I cannot fill here. Okay. Because the series starts from 5. Therefore, it will be greater than 30,000. So this cannot be happen. The only choice I can have is 1. So in this place, I have only one choice. Remember, the number is 2, but choice is only 1. Do not confuse with 2 choices. We don't have 2 choices here. Since the number is less than 30,000, 10,000 place can have only the number 2. So therefore, I have only one choice for the first place. After that, all numbers can be filled in 1000 place. So therefore, here I have 4 choices. Okay, if 2 is and it is fixed, so therefore I have left with 3, 5, 7, 9. So again here 3, 2, 1. Okay, so here 2, 3, 5, 7, 9 I have taken less than 30,000. So therefore 2 is fixed in 10,000 place. I have left with 3, 5, 7, 9. Okay, so I have 4 options or 4 choices for the 1000 place. If one number is gone, 3 numbers are left. Again, one number is gone, 2 numbers are left. Again, the last units place can have only one number. So therefore, for this number, okay, so for this number, our answer is 1 into 4 into 3 into 2 into 1. Okay, so that is 24 numbers. We can find 24 5-digit numbers which are less than 30,000. So let me take the second question now. So second question, greater than 70,000. So I have taken 5 digits here. Okay, so greater than 70,000. From now, you can see here, since greater than 70,000, I have a restriction for my first place. So this is my restriction place. So I cannot fill 2 because it will be less than 70,000. I cannot fill 3. I cannot fill 5. Okay. The only choices I have left with is 7 or 9. Okay. Because greater than 70,000. Greater than 70,000. Therefore, I have only 2 choices here. I have only 2 choices here. Okay. Now, if 7 or 9 has written, in the first place, I have left with 4 other numbers. Let me assume 7 is I have written in this 10,000 place. How many numbers are left? 9, 5, 3, 2. So, how many choices we have in the next place? That is 4 choices. Again, 2 numbers are gone, 3 numbers are remaining, 3 numbers are gone, 2 numbers are remaining, 4 numbers are gone, 1 number is remaining. Okay, so therefore, the total number of digits greater than 70,000 is how much? 2 into 4 into 3 into 2 into 1. Okay, therefore, 2 into 4 into 3 into 2 into 1. Okay, so therefore, how many number of digits we can form here? So, we can form 48. Okay, so 48 numbers can be formed which are greater than 70,000. Okay, so next question, between 50,000 and 90,000. So between 50,000 and 90,000. So now, what do you mean by between? Let me take a number x. That should be between what? So between 50,000. So between 50,000 and 90,000 means the number should be greater than 50,000 and less than 90,000. So we are forming 5-digit number. So that is question number C. So let me write 5-digit numbers. Now, where is my restriction? Again here. So I have a restriction again here from a first place. Okay, so greater than 50,000 means I have an option. So what are the digits I have chosen there? So the digits are 2, 3, 5, 7, 9. So these are my digits 2, 3, 5, 7, 9. So I cannot put 2, I cannot put 3. Why? Because it will be less than 50,000. The number must be greater than 50,000. Therefore, the chances here is 5, 7, 9. One more thing is what? Less than 90,000. Less than 90,000 means I cannot put even 9 here. I cannot put even 9 here. Okay, the last digit is like, for example, before, now using this digits only, that is 7532. This is the maximum number which is less than 90,000 you can get. Okay, so therefore, here we have a restriction for only 2 choices. We have only 2 choices that I can fill only 5 or 7. Because the number must be greater than 50,000 and less than 90,000, it can take only 2 values, that is 5 and 7. So I have 2 choices here. Okay. Now the same concept. One number is removed for the 10,000 place. How many numbers are left? That is 4, next 3, next 2, next 1. Okay. So therefore, what is total number of? So therefore, what is total number of digits here? That is 2 into 4 into 3 into 2 into 1. Okay. 2 into 4 into 3 into 2 into 1. So that is how much? 48. Okay. So next question, the same question. How many 5-digit numbers can be formed with the digits 2, 3, 5, 7, 9 which are greater than 75,000? So remember here, greater than 75,000. Okay. So this is my question, greater than 75,000 using these digits. So look here. 5 digits. Now, greater than 75,000 means, where is my restriction? Again, my restriction will be in the first place. So, this is the restriction. What the choices I have, if greater than 75,000 means, the choice I have left with is 7 or 9. Okay. If I fill 7, okay, if I fill 7 first, let me take 7. Therefore, the series starts with 7. Okay. Next is second place also I have restriction. It is 75,000. So, I have how many choices here? Here also I can fill 5 or 9. So, here also I can fill 5 or 9. Okay. Suppose if I take 9 here. If I take 9 here. So, here greater than 75,000. Okay. So, therefore, my restriction is in the first place because it can take only 7 or 9. Okay. One more restriction is there in the second place, that is it must be greater than 75,000. 75,000. So, therefore, what happens? If my first case is 7, if I start with 7, then I have only 2 choices, that is 5 or 9. If my first choice is 9, then my choice will be 2 or 3 or 5 or 7. So, I have 4 choices. See here, when 7 is taken, I have only 2 choices. But when 9 is taken, I have 4 choices. So, therefore, I cannot take them simultaneously. Okay. So, therefore, I have to split this question into 2 cases. That is, my first case is when digit starts with 7 and my second cases when digit starts with 9. Okay. So, therefore, what happens when digits starts with 7? Okay. When digit starts with 7, so for the 10,000 place, I have only 1 choice. That is, since 7 can be placed there, I have only 1 choice. Here I have what? I can put 2 choices here. So, I have 2 choices here. Here I have 1 choice. Okay. So, here I have 2 choices. Okay, so now 2 numbers are gone. So, remaining places can be filled in this place 3, 2, 1. So, therefore, what happens for my total number of digits here? That is 1 into 2 into 3 into 2 into 1. Okay, so that is 12 numbers. Next, we will go for case 2. Now again here my first choice is only 1. Okay, that is 10,000 place can have only the number 9. Therefore my choice is 1 there. Whereas after the second place, so for the second place I can have 4 choices. Okay, so whatever number you put 2, 3, 5, 7, obviously it will be greater than 75,000. Okay, again now so here I have left with 3, 2, 1. Okay, so what is the total number of digits here? 1 into 4 into 3 into 2 into 1. Okay, so that is 24. 24. So what about the total now? So my total. So total will be 12 plus 24. Okay, so that is 36 numbers can be formed which are greater than 75,000 using the digits 2, 3, 5, 7, 9. So remember, whenever you have the restriction, first notice in which place you have the restriction. Okay, so when you have greater than one restriction, this is in this example you can see you have restriction in both the places. So whenever there is restriction more than one places, okay, so the cases can be divided. Because why I have divided here? Because if I take 7, I have only 2 choice for the second place. But if I take 9, I have 4 choices in the same second place. So I cannot take them simultaneously. Therefore, I am dividing it to 2 cases. There, my first case is digit starts with 7 and my second case is digit starts with 9. Then I'll total it. That is 12 plus 24. That is equal to 36. So this is the total number of digits which are greater than 75,000 by using the digits 2, 3, 5, 7, 9. So next question. How many 4-digit numbers can be formed with digits 0, 1, 2, 3, 4, 5, 6? Remember the condition, digits are not repeated. So here I am taking all the examples where digits are not repeated. Okay, so what are the numbers we have here? We have the numbers 0, 1, 2, 3, 4, 5, 6. That is totally we have 7 digits from 0 to 6. Remember what we have to form? We have to form 4-digit number. So first question is how many of them are odd? Second question is how many of them are divisible by 5? First let me find out how many 4-digit numbers can be formed. Okay, so this is unit, tens, hundreds, thousands. If you put 0 in the first place and some other number like 2, 3, 4, is it a 4-digit number? No. Why? 0 is there, no? So what is my restriction? Where is my restriction? 0 is my restriction. Where is my restriction? It is in the first place. That is 10,000 place cannot take the value 0. It cannot take the value 0. If it takes the value 0, it will become 3-digit number. My aim is to find 4-digit number. So therefore 10,000 place cannot have 0, but it can have any other numbers from 1 to 6. So how many choices we have here? We can have 6. But 0 can be placed in other places. Like it can have, like we can have no, like that 6,021 or 5,034 or like this. So 0 can occupy hundreds or units or tens place also. But my restriction is 0 cannot take place in 10,000 place. Okay, so therefore I have only 6 choices for 10,000 places. So what about 100 places? Now since 0 cannot be taken in the first place, we are left with 6 numbers. So therefore I have taken 6. Now remember that 1 is gone, but 0 can be included to other numbers. Okay, 0 can be included to other places. Okay, so therefore how many numbers we are left with 100? That is 6, not 5. Okay, because 1, 2, 3, 4, 5 we are left with, but 0 since we have not taken in thousands place, we can add it to hundreds or tens or units place. So therefore I have 6 choices for 100 places. Next, tens, obviously 5, then 4. Okay, so my total 4-digit number that can be formed here is, that is 6 into 6 into 5 into 4. 6 into 6 into 5 into 4. Okay, so that is 720. So total 720 numbers we can form. Now we have conditions. My first condition is how many of them are odd. So remember, odd. When you come across odd here. Okay. So now come across my first sub question, that is how many of them are odd. So we have the digits 0, 1, 2, 3, 4, 5, 6. Okay. So the same condition is applied here. We have 4-digit numbers. So therefore, we have 2 restriction here. What is my 2 restriction? Restriction is in my first place as well as the last place. What is my restriction? Why is my restriction is in the last place? Because the number we have to choose is odd. Odd means I cannot write 0, 2, 4, 6 in the last place. So I have only 1, 3, 5. That is, I am left with only 3 choices in the last place. Okay, only 3 choices in the last place. What about my first place? I cannot take 0. I cannot take 0. Both in the last place, both in the first case. Okay, so here 0 is the number where 2 restriction, it is causing 2 restriction. Even it cannot fill in the first place, neither it can be filled in first place, nor it can be filled in the last place. Okay, so therefore I have to choose a number odd. Okay, and 0 cannot be placed in the last place as well as 0 cannot be placed in the first place. So since my restriction is not in 0 for the units place as well as a thousands place. Okay, so my restriction for 0 is both in thousands place as well as the units place. So therefore, since already one number, that is I have only choices 1. So 1 I can fill here, 3 I can fill here, 5, because odd numbers we have to choose. Okay, so I cannot take 0, 2, 4, 6. Now I cannot take 0, 2, 4, 6 here also. I cannot take 0 also here. Okay, 0 I cannot take, and one number from this I cannot take because it is repeated here. So how many numbers are left here? I am left with 5 digits. One is 0, I cannot write. This from any other number, if I have written here, I have left with only 2 numbers. 2 plus other 3 numbers, totally 5 numbers or 5 choices I have in thousands place. Then, okay, but 0 can be filled, included in the hundreds place as well as tens place. So therefore, how many numbers I can write here? Here also I have 5 choices. Out of 7 choices, 2 numbers are gone. So 5 remaining. And here 4. Okay, so therefore, odd numbers, so total odd numbers can be formed. Here is 5 into 5 into 4 into 3. Okay, 5 into 5 into 4 into 3. So this is my answer for the 4-digit odd numbers. So next question, the same question, how many 4-digit numbers can be formed using the digits 0, 1, 2, 3, 4, 5, 6, where digits are not repeated? And my second sub question is, how many of them are divisible by 5? So divisible by 5 means what here? So divisible by 5 means, so let me take 4-digit numbers. Okay, so divisible by 5 means the last number must end with only 0 and 5. But here also I have restrictions. Okay, so where is my restrictions? So now I am taking my second sub question. How many of them are divisible by 5? So what are the digits I have? 0, 1, 2, 3, 4, 5, 6. So I have to form 4-digit numbers. The number which are divisible by 5 must end with 5 or 0. One more thing is, the first place cannot take 0. The first place cannot take 0. So these are my 2 cases. If the first digit is 5, then the last digit must end with 0. Must end with 0, but first digit 0, it cannot be possible. If I write 5 somewhere else, then 0 must be taken the first place, but this is not possible. So here also I have to split the question into two cases, that is first digit starting with 5 and first digit starting with 0. What happens? So first digit cannot be started with 0. So therefore my first case here, last digit is 0. Okay, so this is my first case. If last digit is 0, I have only one choice here. So if 0 is taken already to the last places, so we are left with 6 numbers here, 5 numbers here, 4 numbers here. Okay, so I have 6 choices, 5 choices, 4 choices. So therefore total number of digits here is 6 into 5 into 4. 6 into 5 into 4. That is 120. 120 numbers can be formed. Suppose if my last digit is 5. Again, I'll take 4 digit numbers. If my last digit is 5, the value is fixed. Therefore, I have only one option. Okay, and first place cannot take 0. It cannot take 0. So 5 is already fixed. So I cannot take 5 in the first place. 0 cannot be taken. So therefore my only choice is here 5. Okay, now 0 can be included here. Again, my only choice is 5 and this is 4. Okay, so here I have, so 5 into 5 into 4 into 1. Remember, don't take 5 because 5 is a number, 1 is our choice. So therefore, this is 100. Okay, so how many total number? 120 plus 100, that is equal to 220. See how many of them are divisible by 5? If I take 0 in the last digit, my first place have 6 choices. If I take 5 in the last digit, my first place have only 5 choices. Okay, so therefore I have to take two different cases here where my last digit is 0 and my last digit is 5. So when your last digit is 0, your total number of numbers which are divisible by 5 is 120, and when your last digit is 5, the total numbers will be 100. So therefore your total number of digits which are divisible by 5 is 220. So remember about the numbers where it have to be placed and about the restriction of numbers also. So my next question is, how many numbers between 300 and 3000 can be formed with the digits 0, 1, 2, 3, 4, 5? Okay, so we have 0, 1, 2, 3, 4, 5. First we have to form 3-digit as well as 4-digit numbers. So the number must lie with 3000 to 300. So let me form first 3-digit numbers, 1, 2, 3. Okay, so 1, 2, 3 digits numbers we are forming here. Now 0 cannot be taken in the first place. Okay, so therefore I have only options, that is 5 options. I cannot take 0 in the first place. So therefore my choices are from 1 to 5, that is 5 choices I have. If one number is already taken, but 0 can be included to other numbers also, what is my choice? 5 again. Okay, 5 again. Then it is 4. Then it is 4. So therefore total 3-digit numbers. Total 3-digit numbers will be 5 into 5 into 4. But our assumption is wrong here. Why? They have given the number must be greater than 300. So if the number is greater than 300, I cannot take 2 and 1 in the first place also. I cannot take the 2 and 1 in the first place also. So therefore here is restriction in my first place. Not only for 0 but also for 1 and 2. So therefore if I have to form a 3-digit number, so here I am forming 3-digit numbers. Here, okay, I cannot take 0 as well as 1 as well as 2. Okay, so therefore my only choice is 3, 4, 5. So I have 3 choices in my first place. Next, 0 can be included in other places. 1 and 2 can also be included in other places because it is greater than 300. So therefore I have 5 choices. If one number is taken, 5 numbers are left. Okay, if now one number is gone, we are left with 5 numbers. Therefore, I have 5 choices and here I have 4 choices. So, therefore, how many total digit 3 numbers we have? 60. So, we have 3 digits number 60. Next, less than 3000. So, less than 3000, here I am doing with 4 digit numbers. So, less than 3000. Less than 3000 means the only options I have is 0, 1, 2. Okay, but 0 cannot occupy the first place. So, my only choices are 2. If one number is taken, I am left with 5 numbers. One more number is taken, I have left with 4 choices. One more left and 3 choices. So, here 4 digit numbers is 2 into 5. So, I have 2 into 5 into 4 into 3. So, this is 120. So, how many we can form? That is total 120 plus 60, that is 180 numbers we can form. We can form numbers 180 which are between 300 to 3000. Okay. So, my next question. How many numbers can be formed with the digits 2, 4, 6, 8 without repetition? So, remember here with the digits 2, 4, 6, 8, how many numbers can be formed? Okay. So, the maximum we can form using 1 digit number also. Okay. We can form 2 digit number also. We can form 3 digit number also. And maximum we can form 4 digit number also. So, I will come across one by one. If I write 2, 4, 6, 8. So, they are all 1 digit number, that is single digit number. So, how many we can form? We can form 4. We can form 4 digit single number. When I come across 2 digit numbers, so first place can have 4 choices, second place can have 3 choices. So, totally 12 2 digit numbers can be formed. 3 digit numbers, 4, 3, 2. So, how many numbers we can form? 24. Okay. Come across 4 digit numbers. 4, 3, 2, 1. Here also I can form. So, totally how many digits? So, total number of digits is equal to how much? Okay. 4 plus 2, 6, 6 plus 4, 10. So, total 64 digits. Okay, 64 digits can be formed using 2, 4, 6, 8. They have not specified that you have to form 2 digit or 3 digit or 4 digit number. So, they are asked you how many numbers can be formed using the digits. So, we can form single digit number, double digit number, 3 digit number, 4 digit number. So, if you form single digit, you have 4. 2 digit you have 12, 3 digit 24, similarly 4 digit numbers you can form 24. So, totally you have 64 numbers which you can form using the digits 2, 4, 6, 8. Okay. In how many ways 5 digit numbers can be formed using the digits 1, 2, 3, 5, 7, 8, 9. How many of these are divisible by 5, ending with 25, less than 50,000, greater than 75,000. So, first one, divisible by 5 means the number must end with 5. Divisible by 5 means the number must end with 5. So, I have 5 digit number here. Okay. So, 5 is already fixed. The choice is only 1 here. Okay. So, I have 1, 2, 3, 4, 5, 6, 7 number. 7 numbers. 5 is gone, 6, 1 more is gone, 5, 1 more is gone, 4, 1 more is gone, it is 3. So, total we have here 6 into 5 into 4 into 3 into 1. Remember 5 is a number, not the choice. Okay. So, this is the number. Next, my second question, ending with 25. Again 5-digit numbers. Ending with 25 means we have only one choice for each unit here. Okay, so 2 is a number, not the choice. 5 is a number, not the choice. The only choice for these places are 1 and 1. Okay, so therefore 2 is gone, 5 is gone. Okay, so how many numbers we are left with? 5. Again one number is gone, 4. One more number is gone, it is 3. So therefore the total numbers ending with 25 is here 5 into 4 into 3 into 1 into 1. You can write 1 into 1 or you can leave it. My next question. So less than 50,000. Less than 50,000 means I have the chance only for 1, 2, 3. So my choices for this place is only 3. Okay, one number is gone. So I am left with how many numbers? 6 numbers, 5 numbers, 4 numbers, 3. So therefore for less than 50,000, my total number of is 3, 6, 5, 4 into 3. Next, again we come across greater than 75,000. So we have the numbers. So we have the numbers 1, 2, 3, 5, 7, 8, 9. So that is 1, 2, 3, 5, 7, 8, 9. So greater than 75,000. Greater than 75,000 means here, if first place is 7, then it can have 8, then it can have 9. And 75,000, if my first place is 7, here we have to split it. Why? It can take 7, 8, 9 in the second place also. So here we have to consider 2 cases. Here first digit is 7. If first digit is 7, so I have only one choice left. And 75,000, so therefore here I have the options for 5, 8, 9. Okay, it must be greater than 75,000. So therefore here I can choose 3 numbers. Okay, now 2 numbers are gone, that is 2 numbers are gone. We are left with 5, 4, 3 number. So here I have 1 into 3 into 5 into 4 into 3 numbers. My next case is first digit is 8 or 9. Okay, 8 or 9. If it is 8 or 9, I have 2 chances. If 8 or 9 is filled, I can have any number here. So that is I am left with. If 8 is filled, I have 6 choices. Or if 9 is filled, I have 6 choices. That is 5 into 4 into 3. So therefore here I have 2 into 6 into 5 into 4 into 3. Okay, so here it is 180 and here it is 720. So therefore my total numbers is 180 plus 720, that is equal to 900. So we can form 900 numbers which are greater than 75,000. Next, formation of numbers with digits repeated. So digits repeat, what happens? How many different 3-digit numbers can be formed using the digits 1, 2, 5, 4, 6, 8? So my aim is to form 3-digit number. I can fill any number from 1 to 8. So I have 5 numbers. I can fill all the 5 numbers. Here also I can fill all the 5 numbers. Here also I can fill all the 5 numbers. Because see, if digits are like this, 2, 6, 6, 8, 2, 8, 1, 1, 1. So in all the places the digit is being repeated. So therefore I have all the choices for the places. So here my answer is 125. How many 5-digit even numbers can be formed using the digits 0, 1, 2, 3, 4, 5? I have already said you that if nothing is specified in the question, you should consider it as digit being repeated. Okay, so I have to form 5-digit even numbers. It is clear that we have already done 0 cannot occupy the first place. So therefore I am left with only 5 choices. Okay, I am left with only 5 choices. But one more thing is even. Even numbers means I cannot fill 1, 3, 5 here. I cannot take this. Okay, my only choice for this position is 0, 2 and 4. This I cannot take because I have to form even number. So therefore here I have only 3 choices. Now 0 can be included to other places but not in the first place. So therefore, so one even number is gone, you take. 0 you can't take. So how many? 1, 3, 4. 4 numbers you can fill here. Now 0 can be included. So therefore you have 4 choices. Okay, next. So now you have only 3 choices for the last place. That is, you can take only 0, 2, 4. Now 0 cannot take place in the first place, okay, because it will not form 5-digit number. So I can fill any other number. So I have 5 chances. Now 0 can be included to other places. So therefore you have 6, 6, 6 because the digits can repeat. So therefore here my answer is 5 into 6 into 6 into 6 into 3. Okay. So this is how 5-digit even numbers can be formed. So digits can be repeated since it is not specified in the question, but even place that the last place cannot take 1, 3, 5. It have only choices 0, 2, 4. Therefore, I can take 3 options or 3 choices here. My first place cannot be 0. So, except 0, I cannot take all the 5 values. So, therefore, 5. And other 3 remaining place can be take all the digits from 0 to 5. Therefore, you have 6, 6, 6 choices there. So, therefore, my total number of digits will be 5 into 6 into 6 into 6 into 3. Okay, so this is all about how the numbers being repeated and how the numbers do not repeat. Okay, so in today's class, what we have learnt is how the number can be formed when digits cannot repeat and when digits can be repeated with restrictions, without restrictions. So I hope you all understand and enjoyed today's session. So we'll meet you in the next session. So till then, keep watching, keep learning and keep exploring. Thank you.